All right, this section's over adding, subtracting radicals. Pretty similar to the last section of multiplying and dividing, where we can only add and subtract radicals that have the same index. For instance, if I have the square root of 3 plus the third root of 3, I cannot add those together because the indexes are not the same. Well, there's also another kind of part to this as well. The indexes have to be the same, so they have to be the same here. But then also the numbers underneath the root have to be the same. Okay, so what I mean by that is, if I have the square root of 3 plus the square root of 3, I can add those together, and I actually get 2 times the square root of 3. You might be like, well, where did that 2 actually come from? Well, there's technically a 1 in front of this one and a 1 in front of this one. Okay, square roots or cube roots or any kind of root acts as though it's a variable. So if I picture this as an x, I have one of them, plus this is an x as well, and I have one of them, I get 2x. Well, we know x was the square root of 3, so that's why I get that. I have to make sure the indexes are the same and the numbers inside are the same. Because if they're not the same, then I cannot combine them. So first 2 up here. If I look, this 2 and this 2 are exactly the same. So I take the coefficients and I combine them. So that's a -1 square root of 2 minus 2 square root of 6. You're like, what? That's it? Yeah, that's it. I can't do anything with the 6. I can't even break it down because it's 2 times 3 is what 6 is, and I can't take anything out, so it has to stay there. So that's your answer, ladies and gentlemen. This number 2 here, what do I see that's the same? Square root of 6, square root of 6. So -1, -1, that gives me a -2. Square root of 6 minus 2, square root of 2. Guess what? I'm done. Man, this is complicated stuff. Go ahead and try these 2. Pause and then play. I can combine the square root of 6, square root of 6, and a square root of 6, so I have all of it combined. 2 minus 2 gives me 0. Minus 2 gives me -2 square root of 6. This one here, square root of 3, square root of 3, combine them. -1 plus 3 is 2, square root of 3 minus 2, square root of 6. Now, some of you might be like, well, can I write it differently? Yeah, that's okay as well. As long as you make sure the negative follows that, and then this is a plus, that is also the same thing. Either one of those are the same, and that's okay. Well, what happens when I have numbers that maybe can be broken down? Well, we have to find it out. So 24, I'm going to break down 24. 2 and 12, 2 and 6, 2 and 3. So this is negative square root of 2, 2, 2, and 3. Okay, I'll leave that for right now. Let's go to the 54. That's 2 and 27, 3 and 9, 3 and 3. So this is minus the square root of 2, 3, 3, 3. Plus 3, now let's go to the 20. 2 and 10, 2 and 5. So square root of 2, 2 and 5. All right, let's see what we can do. Yeah. Let's look at the first square root of 24. Because it's a square, I can deal with 2 of them, pop 1, cross 1. So that's a -2 square root of 6. Let's go to the next one. Minus. I need a group of 2, so 1 pops, 1 gets crossed, the 3 popped, what stays in? Oh, a 6. Ooh, now it's looking a little nicer. Then let's go to the square root of 20. The group of 2, 1 pops, 1 crosses, becomes a 6, square root of 5. All right, now I have a square root of 6, square root of 6, -2 minus 3 is -5, square root of 6. Plus 6, square root of 5. Boom goes the dynamite. You are done. Let's come over here to this 6 here. 27. 27 is 3 and 9, 3 and 3. So that's negative root 3, 3, 3. Minus root 3, minus root 3. You notice I can't break these 2 down. That's why they're staying there as a root 3. Now I have a group of 2 3s, so 1 pops, the other one gets crossed out. So the 3 pops out with a negative 3 out there already. Square root of the 3 that stays minus root 3 minus root 3. Oh yeah. 1, 2, 3, they're all the same. So negative 3 minus 1 is negative 5 root 3. That is your final answer. All right, let's go to 10 and 11 here. And let's go from there and see what we can do here. With 10, you'll notice that we have some numbers outside coefficients. That's okay. That doesn't really matter. But I can see if I can break it down. So the 8 is 2 and 4 and a 2 and a 2. So this is really 3 times the square root of 2, 2 and 2. Plus 3 square root. Let's break down 54, shall we? 2, 27, 3, 9, 3, 3, 2, 3, 3, 3. Boom. That's simple. Minus 3. Let's see if we can break down the 18. 2, 9, 3, 3. So root 2, 3, 3. Oh yeah. Now let's see what happened. A 2 pops, a 2 gets crossed out. So that becomes a 6 root 2 plus. 3 pops out, 3 gets crossed out. So it becomes a 9. 3 times 3 is 9. Square root of 2 times 3 is 6. Oh yeah. Minus. Group of 2 3s, 1 pops, 1 gets crossed. It becomes a 9. 3 times 3 is 9. Square root of 2. Oh, yes. Sounds great. I have a root 2 and a root 2. 6 minus 9 is negative 3. Root 2 plus 9, root 6. Oh, yeah, I'm done. Now, let's look over here at 11. This will be the last problem we do for this particular section, this video. Oh, yeah. Okay, here we go. So, what did we say? We can only combine roots if they're the same index, which they all are. Yay, they're great. They're all the same. But the numbers underneath the root, we call them radicands. That's not necessarily important, but we do call them radicands, as opposed to radicants. Ha, 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 ha. Ha, ha. I just had to do that. I'm sorry. So these are all the same, these 6's. So what I can do is take the negative 3 and the minus 1 to get a negative 4. 4th root of 6 minus 3, 4th root of 3. Well, some of you might be wondering, how come I didn't take the 6 up here and do a 2 times 3? Well, because nothing can pop out, so that's why I didn't even waste my time on that. If you can be the judge and say, hey, none of those have 4 of them in there, or 4 numbers aren't in there, then you can just kind of go from there. If you need to check, please check, but if you don't need to, then you don't have to. So there we go there. You know what, let's do one more. What the heck? Just for the fun of it, you know? Might as well. Yeah, let's do 15. Let's do 15. This one looks great. This one looks lovely. Okay? Again, we got big numbers, so let's find out 64. 64, 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2, holy cow, negative 3, 4th root. How many 2's are in 64? We got 6 of them. 1, 2, 3, 4, 5, 6. All right, these 486's are great. I only have to break down one of them. So let's go over here because it looks like it's a big number. 2 and 2, 43. I think that's right. I don't even know. I think so. This is 3 and an 81. That's a 3 and a 27. That's a 3 and a 9. That's a 3 and a 3. That looks pretty good. Plus 2, 4th root of 1, 2. And then I have 1, 2, 3, 4, 5 3's. 1, 2, 3, 4, 5. Minus 2, 4th root of 1, 2. And then 5 3's. 1, 2, 3, 4, 5. Boom goes the dynamite. Now let's see what can happen. Because this is a 4th index, that means I need 4 numbers that are the same. 1 pops, the other 3, they got forgotten at Kmart. The 2 popped out. Becomes a negative 6. 4th root of 4. How did I get 4? 2 times 2. Plus, I need 4. So I have 4 3's. 1 pops. The other ones, in this case, they got left at Walmart. So 2 times 3 is 6. 4th root at. And then this 2 times that 3 is a 6. Oh, yes. Hopefully we are kind of making sense. Minus. I got 4 3's again. 1 pops out, the other 3, they got left at the Grand Canyon. So it becomes a minus 6 again. 4th root of what? 2 and 3 make a 6. Now let's see what I got left. Oh, I can combine that and that. So I got negative 6, 4th root of 4, because this goes here. 6 minus 6 is 0. So plus 0, 4th root of 6. So that's my answer, right? Wrong. Why is it not? Because this is just 0. So that can go as small as you want to, which becomes a 0. So my answer is negative 6, 4th root of 4. Oh yeah, that's my answer. All right, that concludes this video. If you need any help, again, go back, rewatch it. Make sure you take notes. Pause the video when it tells you to pause. Make sure you're taking notes and writing stuff down. Ask questions, do problems, be successful.